Hey, my name's Casey, and I'm going to walk you through LeetCode 926, flip string to monotone increasing. And if you want to see more videos, you can subscribe. Okay, so in this problem, all they want is the minimum number of flips to change some input string to where all the zeros come before the ones. Or another way of saying that is where all the ones come after the zeros. So for example, in this here, all they had to do was flip the last bit to a 1, and now we have all zeros followed by all ones. Cool. And this string, they flipped this bit here to a 0, and they flipped this bit here to get all zeros followed by all ones, and that only took 2 flips. Okay, so we know what they want. So what do you have to realize when you're doing this problem? When you walk through it, let's just say I'm going to make up a string off the top of my head. Let's say I start with 0. And I'm not going to tell you what the rest of the numbers are. I'm just going to feed them to you as I go. So if I start with a 0, cool. I don't actually care what the next number is, right? It could be a 0 or it could be a 1. It doesn't matter because it's either way it's going to be valid because 0, 1 is valid and 0, 0 is a monotone increasing string. So let's pretend that the next number is a 0, and another 0, and another 0. We still don't care what the next number is. Well, suddenly now we care what the next number is because now that we have a 1, if the next number that comes out is a 0, we have to flip something. So that is actually like the entire intuition behind the problem is for every 0 that we get after a 1, something has to flip. So either this 1 has to flip or this 0 has to flip. So this could turn into this, or this could turn into this. Okay, cool. So and let's just pretend that this wasn't another 0. Let's say another 1 came out, right? And now let's say another 1 came out. So now we have 3 1s. Well, these are 3 1s that we will potentially have to flip. We might not have to flip all of them. We might have to flip none of them. But they are potential flips, essentially. Okay, so let's say I give you another number and it's a 0. Well, I know that I have to flip something, either this 0 or this 1. They have to cancel out. If I give you another 0, well, guess what? Something has to flip because there are 3 1s that came before these 2 zeros. And once again, if I get another 0, I know I have to flip something. And so these could turn to all zeros, or we could change these to all 1s. It doesn't matter. We don't actually need to return the strings. We don't care. We just know that something has to flip in order for the string to be correct. So and if I keep getting, let's say I get another 0, and another 0, and another 0, well, these 3 zeros that I just added, nothing has to flip anymore, because these 3 zeros that came after those 1s, they essentially cancel out, because we know that we've corrected the problem up to this point. And whatever comes out, so if we just get a bunch of zeros, so if we got all zeros here, or if we got all 1s here, it doesn't matter, because we know that we've corrected the string as the zeros were coming in. So that is actually the entire algorithm. As long as you just have to keep track of the number of 1s that you encounter, because these are potential flips, and any zeros that come after, well, those are issues that will get canceled out with the potential flip. So essentially, any 0 that comes in after a 1, we have to flip something, and then our flip count goes up in order for the string to be correct. So hopefully I've worded that to where it makes sense. And now we can actually just code that algorithm out. So we just need to keep track of the number of 1s, because those are potential flips, and any zeros that come after those number of 1s, our flip counter will go up, or the number of flips that will go up. Okay, so let's just make a variable for a number of flips, and it's going to start at 0, and we can get rid of this. Okay. And we just want to return the number of flips by the end of this method or whatever. So we need to loop through our string for char c s.to char array. Okay, so we're just going to loop through our string, and now we need to check if the character is a 1. So we need to keep track of our number of 1s that we encounter, because these are the potential flips. I'm just going to call it num1s. So if we encounter a 1, we need to sorry, not decrement, increment our number of ones, because think of this as the potential number of flips. I could just call it potential flips, but now I feel like this is just more easier to read. Okay, so we increment our number of ones. Otherwise, if it's not a 1, it's a 0, right? And if it's a 0, and the number of ones, or aka, or also known as the potential number of flips, is greater than 0, well then we need to flip something in order to correct our string. So we increment our number of flips, and now one of those potential flips, or the number of ones, just gets canceled out, and we decrement our number of ones. And that is the entire algorithm. So let's run it, submit it, and boom, we're done. So yeah, if you like the video, you can give it a thumbs up, and if you want to see more, subscribe. Cool.